So before we jump straight into building a database, I want to just spend a little bit of time talking about your data structure to make sure that we get the database foundations correct. Within the database world, there's lots of different terminology, and one of these is data normalization. And this is the process in which information in a database is organized and structured efficiently by breaking it down into smaller pieces. So where possible, we should look to try and break your information down into logical groups, such as things like company information, project information, qualification information, etc. To try and illustrate my point about data normalization, this is a fairly simple spreadsheet where we're trying to track engineers connected to a company. In this example, we have 3 engineers and we have 3 companies. So just to walk you through this in a bit more detail, on row 2 we have a company called Bricks and Mortar, and they have 3 engineers, Tony Lavers, Julie Ford and Simon Gillins. Now the issue with this is this works okay if we only have 3 engineers and we only want to capture very limited information, as in this example just their email address. But if we want to add more engineers, we have to add more columns. So this makes scalability an issue. It also means that we aren't able to easily report on engineers or list of engineers by each company. To try and further illustrate data normalization, this spreadsheet is set up very differently. We have a column with all the engineer names in, and the first column is the company name. So each engineer is connected to one company. This is much more scalable because if another engineer was to join, we can certainly insert a row and then add the details for the engineer connected to that company. In a database, this would be known as a one-to-many relationship, where one company can have many engineers. Before I share with you the diagram of what we're going to build in this series, I just wanted to cover a couple of different terms that are different between spreadsheets and databases. Now, I think most of us will be fairly comfortable and used to dealing with spreadsheets, and what we're looking at here would be a worksheet for engineers. So in a database, this would be a table, so it would be a table of engineers. And in a spreadsheet, this would be a column, which in a database would be a field, and a row would be a record. Also in a spreadsheet, on a column, you can call a column whatever you wish, but in a database, they have attributes. So for instance, in a database, if you add an email field, it will only accept an email, whereas in a spreadsheet, I can obviously put anything in here I like, and it will be very happy to accept that. And that's actually part of what's called data validation, making sure that the information that you add to the system makes sense. This is a simple chart of what we're looking to build, so let me just run you through this. We'll have a main companies table, and each company will have multiple directors. Each company can have many projects, and each of those projects can contain documentation and project cost information. Each project will have a project manager connected to it, and also multiple engineers. And each of those engineers will have various qualifications. This diagram gives us a very simple chart just to show us our data structure. It's not a true ERD or entity relationship diagram, as it doesn't show the one-to-many connections between the objects, but just gives us a good feel for what our logical objects are, such as companies, projects, documentation, etc. I hope you found this short orientation useful. In the next video, we're going to be building the companies table and the live app page. So if you haven't done so already, head over to knack.com and sign up for a free account, and I'll see you in the builder.